Today we shall talk about sensitivity of ordinary least square to outliers. We have data on growth rate, GDP growth rate and trade share. Average growth rate from 1960 to 1995 and trade share data. These are 65 observations. So we regress now growth on trade share. Before we regress, we make a scatter plot. And when we make a scatter plot, you see these values are concentrated here and one value is here, and I have labeled it Malta. How I do label this Malta, I'll explain it at some other time. Now, when we regress growth on trade share, you see we use slope equal to growth and trade share, and we get value equal to 2.306. Means if trade share increase by 1%, GDP growth rate will increase by 2.3%. Now, similarly we have intercept, which is 0.64. But you see we have a slightly unusual value here, Malta, and if we remove this value, what happens to this equation? We take it in another sheet, and here I have deleted the value for Malta. Here you have Malta, but here you don't have value for Malta. So you see pattern look altogether different, and your slope is 1.68 and intercept is 0.95. So a single value can change the whole equation by a large magnitude. Why does it happen? As we minimize sum of squares of residuals in OLS, when there is an outlier, this line is pulled towards outlier, so that sum of squares of residuals are minimized. But when we don't have these outliers, OLS performs really well. When we have these outliers, this line moves slightly away from these points and come closer to this unusual value. As a result, your line is a bad fit through OLS. So in place of OLS, we should use some other method like least absolute deviation method when we have outliers in our data, and we cannot delete those outliers. We cannot take those outliers outside of our data. I hope this will be clear to you that how OLS is sensitive to outliers, and how outliers basically misrepresent our data, lead to misleading results for our data. Therefore, be watchful about your outliers and always plot your data before fitting your regression lines. Thank you.